Thank you, sir.
So recording is very important. Please interrupt me at any point of time if we are not recording. Yeah. So now for this particular node of this particular element, element is 1, here the element number is 2. And for this particular element at 168.4, the local number is 1. And the coordinates of that particular node is like a 12 meters in x direction and 0.8 meters in y direction. And if you see the displacement, total displacement, delta ux actually, the total displacement in x direction, if you see, there is no. And if you see the displacement at y direction, it was showing that it is like 0.027 in the negative direction. Here the minus indicates that it's just a negative direction. Now, if you sum up these two like a delta of like x and y combined displacement, that if you are calculating it, that is x cos theta plus y sin theta. If you do that, actually it is coming it as like a 0. So overall, actually, if you see individually, a considerable displacement was there in few nodes at both x and y direction. But if you combine together and if you see that overall, it is coming to an equilibrium conditions all the time. This is how you have to read this.
So,
This
where is the
this is
settlement?
an output table of doing any kind of an analysis. If you do, this is what is the output table that you are getting it.
So, this delta U shows the settlement or something else?
It is settlement.
Okay, fine. Thank you.
If something else here, you can see that like you can see the coordinates of, I mean, you can see the units of this particular thing. If it is a stress, surely it is not in meters, right? It is in MPa, meter per second square. Okay, this is how you can able to read this particular table. This is an output table. This is not the input table. And this is not the incremental displacements. This is just what recorded in the solution. Is that clear, Vivek?
Yes, sir. Clear.
Okay, fine. Thank you for bringing this. Okay, fine. Moving. So shall we move on to our regular topics?
I have one doubt.
Yeah, Bharat, sorry, you also raised your hand. Yeah,
Yes, sir.
tell me, Bharat.
I have modded two problems, one by taking 6 noded element and
Okay.
another by taking 15 noded element.
But you
But
didn't have seen any difference between these two.
there will be minor difference somewhat.
Yeah.
Almost negligible.
See.
Okay. I have another more doubt.
Hmm.
How can I calculate the total settlement happened? Because I had upon 3 stages, I have incremented the load.
Hmm.
But in each condition, it will be showing different deformations. That is for that particular load or what?
That we are going to cover it in the Plaxis viewer part. So viewer part that we have not yet come across it. So I'll tell you that phase-wise displacement, how you need to see, and incremental displacement, how you need to see that.
Okay. In later, before class, we have you have tell that in during first phase, some 10 kilonewtons.
Yes.
There it will show some deformation. Again, you have increased some load. Again,
Yes.
it will show some deformation.
Hmm.
That means that will be the incremental one or individual for that phase.
Individual for that
Okay.
particular case, it is showing like that.
Yeah, that is the doubt. Okay.
Yeah.
Okay.
Yeah, Vivek.
Suppose we are calculating or doing analysis for the 15 loaded elements, and suddenly we have to change from 15 to 6 noded elements. So we just have to change that part only in project window, or we have to change something material properties or soil properties as well?
If your material properties are not changing, you can freeze that and you can change only that particular property. But if you would like to change your material properties also, even there is a feasibility that you can do that.
I'm saying that I have to assign again material properties. I have to assign them again for six
No,
noded
no, no,
elements.
no, not required. If you are changing only the value, it is not required.
Okay,
From
okay.
where we have to start? Sorry.
Sorry.
Suppose I have done the staged construction also.
Okay.
After finding the deformation, now I have to change the mesh, like some course to fine,
See,
or I want to change the nodes from 15 to 6.
hmm,
Is it possible?
see, when you are changing the base structure, anything is possible. But when you are changing the base structure, it is must and should that you have to remesh the model.
Wow, that's
Because
okay.
anyways, software first you told that it is a 15 noded element. Now again, you are asking to do it as a 6 noded element. So it has to redo that particular mesh part. But
Okay.
remaining things and all, you don't want to change anything. So if you remember this in the last class that we did it, I just went for the mesh. In the
Yes,
soil, if
yes.
you just go for the file project properties, here you can just choose it. It's a 15 noded. Now, the moment when you choose it as a 6 noded, say, okay, see, what are all the steps again that you need to consider it? Here it was displayed. See the color difference.
Yeah.
Okay, so now when again I just go, okay, that is not the case. I come back with 15 noded element. Again, it will ask because the moment when you change the option at the back end, it will delete the mesh. So it is must and should you have to come here and I'm not changing anything. I'm just simply generating the mesh. Simply generating the mesh, going for flow conditions, nothing changes. Stage construction, nothing changes. Simply solve the problem again. That's it. Okay, so I've not done any. If you wanted to change the mesh, it is simple. You can just go file project properties. You can change it at any point of time and you can do that. Now, while doing it, this particular things, it is like a 10-10 phase. But then later on, if you would like to add or change any particular values, okay. Now in the phase 2, that if you are running it, maybe it is for 10 loads, right? But in phase 3, you want to put it as only some 5 nodes or something like that. Even that's also possible. Click on this pipe, click on this particular load and check what is the value you have it, line load. The line load is 20. Now just make it as 10 here itself. 10, and then you can start running the analysis again. Okay, now question is like, Sai, I have developed a very big model that which is having, if you see in the stage construction, it is having some 25 phases or 30 phases. For a small change, if I started off rerunning all the analysis, it will kill my job. It will kill my time. So what you can do now, only the phase 3 is changed, but before that, nothing was changed, right? So once it is done, the tick mark is there, no green tick mark. You just click on this one. Again, only that particular phase results, it will ask you to calculate it. Now it's 10, so you can just simply calculate only that particular phase results. Now it's a time saving process for you. Okay, now addition to this particular phase 4 you went, and now to this phase 4 that I wanted to run the analysis with the different materials. So first of all, let me check if we have a different material or not. Okay, so I'll just bring this some deep sand. Now to the phase 4, if I click on this, this is existing with the 10 kilonewtons because it is going to take the image copy of the previous phase. And this particular material properties, you can just right click it, soil, set soil material, set with the deep sand. That's it. Now it is with the deep sand, the 15 noded. After that, it again, the soil properties, everything got changed. That is what actually we were assuming it. So this is where when it will be helpful, after a few days of a time, you realize that your soil material properties are changing over the environmental changes, in that particular point of time that you have to provide a different density of your soil. So that's possible now. So just simply run this and then it will create the solution. So like this, you have a complete flexibility of this. We will come to that particular structure, each and everything. So for that, actually, oh, something wrong.
Command has become QQQQ. Automatically it is taking. Some button had
Okay.
must have got pressed in.
So come on. Hey,
Keyboard cards.
I'm using a wireless keyboard only. Oh my God. What's this? Okay, fine. No issues. I'll just come back to here. Sorry for that. I have something for you guys actually. So related to that, actually, you might be getting confused like how to build that particular phases and what is that in each phase it says that and what need to be an understand for that and all. I have a slide how it is going to be. So if it is in this direction, what is the meaning of this? If it is in this direction, what is the meaning of this? I would be covering up all these particular things. Okay. So this particular PPT, it is already available in the wiki. So whenever you just wanted to have a look, you always prefer to go and look here. This is Plaxis intro. That is where plane stress and plane strain models that we have seen it. And this is where. So just, oh, I got to know how to stop this. Yeah. So all the videos to the images, everything it is getting uploaded over here. And to this, actually, you can just go whenever you want it. You can just use this to download the presentation. So this presentation is available over there. Okay. So what we have discussed already about what is a 15 noded and what are the 6 noded element and what are the things that is coming, everything. And now we already seen what is an axisymmetric model and what is a plane strain model and all. And we have already gone through like the geometry, soil structures, mesh flow conditions and stage constructions, everything. And now coming on to this particular analysis type, I would like to say a very first problem that you have solved something, because if you just see into this close the Plaxis. So when you just see into this stage construction, that you have realized it one thing. So in the stage constructions that what you are doing, there is an initial phase. So in the initial phase that you are not doing anything or something. Yeah, just run the quick queries. If it is all good, let me go. Yeah, if it is like an initial phase, in the initial phase, I told you that there is a KO procedure that we were following it. Okay. And when should we follow the KO procedure and when you should not follow the KO procedure? That's the important thing that you need to remember that. So for that, actually, what I have. System is behaving weirdly. But still, you guys can see my screen, right? Can you see my screen?
Yes, yes, yes.
Okay, fine.
Yes.
Yeah. Okay. So the initial conditions there actually, if you would like to select the KO procedure, in the picture, you can see that the KO procedure, it indicates that the soil layers are like either it's a single layer or it is there, but it should be a continuous soil layer. There should not be any abnormalities on the surface. It should be a continuous soil layer. Okay. But when you want to use a gravity loading is something like at the top layer of your surface. I mean, the initial borehole information itself is like this, you got it, or you want to start the analysis from this particular position when a soil is like this. For this kind of a things that when you want to start, then you have to go with gravity loading, or in this particular soil itself, if there is any kind of a breakage, like our excavation is already done, and from that particular point onwards, you want to consider that. So in that particular cases also, you have to consider it as like gravity loading. So when to choose a KO procedure and when not, when to choose a gravity loading is like if your top surface, I mean, the top layer of your soil, if there is nothing abnormality on that particular surface, and if it is a complete planar and a smooth surface, then your Jackie's formula will apply over there. So you have to consider that as a KO procedure. But KO procedure will not valid when there is an excavation or when there is a misalignments onto the smooth surface. So in that particular cases that you have to use the gravity loading, that you have to use the gravity loading. So is it clear that when you just go for the Plaxis from next time onwards, when you just go into the phase construction, so in the initial construction here that you have an option to choose it the KO procedure or it's a gravity loading. Now you got an answer that when to choose a KO procedure and when to choose a gravity loading. Any doubts on this?
No, no.
Okay, so please be remember this. By mistake, if any kind of an embankment it is there already, embankment you are taking it and then you are trying to apply a load on it and then you need to study it. In that particular cases, embankment structure is something like this. So you have to consider your particular problem. You have to consider your particular problem as a gravity loading, not as a KO procedure. Okay, so you have to be very careful about that, which one that you need to
Then when
select.
do you use the KO procedure, sir? Sorry,
When you have like a planar surface, like you have a borehole
Uniform.
information, uniform, the top layer should be uniform
no, without any loading.
without any loading. That is why I'm calling it as the initial conditions.
Means consolidation by its own weight. Is it like that?
Yes.
Hmm. Okay.
Okay, so is this clear, right? So when you are doing of your particular own problem, now you have an idea that when to choose a KO procedure and when to choose a gravity loading. Okay. Moving on to the next one. So
Excuse
now,
me,
sorry.
Sai, I want to ask you something.
Yeah.
In case there is a structure present, not a embankment and something else. It's a structure. Suppose a building is present.
Hmm.
So in this case, we have to choose gravity loading or KO procedure.
See, structure it is structure is already present, and from
Yeah.
that particular point of time, you want to do the analysis, right?
Yes. Yes.
Then it is obviously it is a gravity loading.
Okay.
Because when you just consider this, there is a structure. Uniformity is not there at the top surface, right? Top surface would be like above the
Building
structure. That should be the top surface, I can say. Building top.
Okay. Okay. Fine. Thank you.
And building top to the soil, there is an inclination. So in that particular cases, you have to consider the gravity loading.
Okay. Thank you.
Yeah. But in Plaxis, your things will really come in picture when you are doing any structural analysis. This is highly possible for your cases. But in Plaxis, Plaxis is meant to study the soil behavior, not the structure behavior. Meant to study the soil behavior. So that's why we always stick on to the soil first, though if you have the structure also, it is recommended in Plaxis. First build the soil as it is, do the KO procedure. Over that and the first phase, you start building your structure. This is a process that which will gives you like more accurate results. Got me?
Yeah.
Okay, fine. Yeah. Now, so initial conditions itself, you have something called as a flow conditions here. So when you just go for this particular thing, in the last class also, I told you that I'm going to cover up this. So if you just see the pore pressure calculation types is like pneumatic or it's a steady state groundwater flow it was. Okay, so what you need to do that pore pressure calculation type here. So if it is like a pore pressure calculation type, which one that you need to choose? If it is a groundwater level, I mean, if your water level is a default that which is coming out from the borehole, you can go introduce 10 different boreholes. And in that 10 different boreholes, each borehole is having a different water levels. So that the water level end of the day, it may looks like this, but this is a borehole information. That water is like a borehole information. If your water level is a borehole information, then you have to always choose pneumatic. Okay, now if your water level is not the borehole information, but you are defining your own water level. It is not the borehole information, but you are defining your own water level. Like if you just go here and to the flow conditions, this is my borehole data, I got it. That's why it's showing it as a global. But now I would like to create a new water level, and this particular water level, it says like this. The new water level, it is like this. Okay. Now, when you just wanted to go for an analysis, and if you would like to, instead of this particular water level, if you would like to consider the new water level that it is there, then in this particular case, that you have to choose the calculations as a steady state groundwater flow analysis. Oh my God, what happened to this?
Okay, sir.
You have to choose in this, you have to make sure that this is the steady state groundwater flow condition. Okay. When you just choose the steady state groundwater flow condition, don't feel that automatically your water level it is applied over here, because you have created here one, but when you are trying to solve your problem, you might be creating a multiple water levels. So now when you just go to your stage construction and when you just click here, okay, you're telling to the software, please consider the manually drawn flow condition. Okay, that is what the information that you are following, telling to the software. But you have to, which one it need to consider it. So that particular conditions that you have to go for this modal conditions. Okay, remember this modal explorer, which is a very complex one. Someone join. Yeah. Remember this is a little complex one in Plaxis. So we are going to cover up this. So in Model Explorer, if you expand your model conditions, in the model conditions, if you expand your water, in the water, actually, what it is there, this is a borehole level, borehole water information it is showing it. Now here, it is a user level water 1 or user level water 2 that you need to select it. Now, if I select this as a user level water 1, now this particular water will amplify over here, reflect over here. And if this particular water level, it is changing it, and if you would like to solve, that can happen only with this. if you select this as a pneumatic water level condition, so again, what will happen is like your software, though here it is not showing properly, but it will not read the results correctly. Maybe for visualization, it was showing something over here, but for your calculations, it will consider the borehole water level only. So if you would like to consider your own user water level, you have to make sure that always it is a steady state groundwater level. Okay, which steady state groundwater level? Yeah, now I wanted
Phase
to
two.
go with this. Okay, so this is what it is telling it. So now you got to know in the flow conditions, actually, I mean, pore pressure calculations. So your analysis will always try to calculate the pore pressures, right? The pore pressures I need to calculate by considering the borehole water level or by considering the user defined water level is what you are telling to the software. That's it. If you are telling that it is a steady state groundwater flow, that is like user defined water level, then which water level also you have to select it. Then accordingly, your pore pressure will calculate it. Otherwise, there you select it as a steady state groundwater flow conditions, but in the model conditions, if you are selecting it as a borehole information only, then your software will calculate the pore pressures based on the borehole water level only. Okay, so please be remember that. So initial phase, here you have to go for pore pressure calculations, when to choose steady state groundwater flow or when to choose pneumatic level. And based on that, like which one that you just need to select it over here. Any doubts on this? Is this clear? When to select which one?
Yeah, but hello.
Yeah.
But suppose if I have 4 boreholes, which is 10 meters apart,
Hmm.
in each and every borehole, suppose in borehole 1, the water level is at 1 meter depth. In borehole 2, some 4 meters, and in borehole 3, some 3 meters. In that case, which one it will consider?
Borehole only you need to consider because that is a borehole data. If you
No,
collect my votes,
I have 4, 5 boreholes, which have
you have
different
10
water
boreholes.
table.
I have already told you an example. If you have a 10 different boreholes and each borehole is having a different water levels, in that particular cases also, you have to consider it as a pneumatic only because that is a borehole information.
That means it will consider the worst condition default by default.
Yeah.
So we should
Okay.
avoid the borehole condition in general for a project.
No, not like that.
Mhm.
It's of your choice, maybe. I can't comment on it, but it depends upon situation to situation.
Okay, then it is taking the, let us say, average, let us say weighted average or something, in which it is ignoring the variation in the water table level, borehole to borehole.
It is considering, see, when your initial borehole water level, it is not always straight. If you have a 10 boreholes, even that can be happen in this way also.
Possible, not in one borehole 1 meter, another borehole 3 meter, but there
Yeah,
can be
it is possible.
variation.
There will
To-
be with that
variation is
particular
possible.
variation. Oh my God. Okay. Don't complicate yourself on understanding the things. Okay. If you want to calculate the pore pressures in your solution with respect to the borehole data, then make sure that in the global water level, the borehole is selected. If it is not the borehole data, you want to calculate the pore pressures with your own defined water level, then choose this particular water level.
Okay.
If you are choosing your own defined particular water level, then make sure that in the calculations, you are selecting it as a steady state. But if you are leaving it to the worst conditions like the borehole itself, then choose this as a groundwater level. That is a pneumatic.
Wonderful. Thank you very much.
Yeah.
Very clear.
Okay, so now moving on to this. Now, if you see this, in the initial conditions, I have seen something called like a, first I have seen something like KO procedure or gravity loading, and then I have seen something like a pneumatic or a steady state groundwater flow conditions. But apart from this, there is a something called as an thermal calculation type also, that which we need to address it, right? So the thermal calculation type here, it is how it looks for you. So when you just open any kind of a solutions, now in the general that if you just go, you have like a thermal calculation type. In the thermal calculation type, if you select this, first option that you have it is like ignore thermal conditions. But if you would like to introduce, that is of your choice again. If you would like to introduce your thermal conditions also into the problem, then it is mandatory that you have to choose an option called earth gradient. In your results, if you are worried about the temperatures, then make sure that in the thermal calculation type, you are selecting it as an earth gradient in the initial conditions. Okay, so when you select this particular earth gradient, again in Model Explorer, that you have an option called a thermal flow. In this particular thermal flow, that you have to tell to the software at the top layer of your surface, what is the temperature in Kelvin, and for every 5 meters of a depth, if you are going it, the temperature is increasing about like 0.025 Kelvin per meter. Per each meter, it is going to increase by 0.025 Kelvin. This is how the initial conditions, if you are worried about the temperatures, if you are not worried about your temperatures, then don't touch this option at all. If someone is really, or on your purpose, if you really wanted to see, I want to see what's happening to the temperature also into the soil, then you have to switch on thermal calculations based upon the earth gradient. And this is how you have to feed this, because at the top surface of the earth, there is a one temperature. As you go deeper and deeper and deeper, sometimes it increases and sometimes it is decreasing. Okay. If it is an increasing fashion of your land, then you can say that the base temperature is 293.1 Kelvin, and till this is like for the top 5 meters. Till for the top 5 meters, it was 293.1 Kelvin. Now the moment when it goes to from 5 meter to 6 meter, then actually the temperature will increase by 0.025, that is 293.026 Kelvin per meter will be there when you measure the temperature at 6 meters of depth. You are with me on this?
That's a simple addition of this gradient. 102, 0.025.
Yeah. From at which depth onwards I need to add is like, that is the H reference that you are feeding it. So till like 5 meters, it is 293 Kelvin only. But after 5 meters onwards, for each meter increase, then this particular temperature will add. If you would like to decrease it, put that particular value into negative terms. That's it.
Negative. So this is the case of geothermal.
Yeah. Okay. So this is
Okay.
where this particular option that you have it. So if you just go for here, oh my God, what happened? This. Yeah. Now, if in this particular case, that if you would like to go for this and go for this, now instead of thermal calculation type here, ignore this. You have to choose this as a earth gradient. You have to choose this as an earth gradient. Click OK. And then you have to make sure that thermal flow. And then you have to make sure that the temperature is this. And till how many meters of depth? Maybe till 5 meters or 2 meters or 3 meters. That is your wish as per your problem condition. Till 3 meters of a depth, I would like to stick on with the 293.1 Kelvin itself. But after 3 meters, for every 1 meter increment, I would like to add the temperature of 0.025 Kelvin. Here you want put like minus Kelvin, so it will subtract it. If you would like to go for addition of this, you just go simply add of this. Okay, that's of your value that you are going to choose this. Clear, right? On the initial conditions, how to select thermal types, and on the initial conditions, how to select it's a KO procedure or a steady state groundwater flow condition. I'm telling you again and again and again, please try to watch this particular video 100 times and understand this, because this is going to simplify any problem that you're going to solve. And then the initial conditions, when to choose a KO procedure and when to choose a gravity loading. Is this clear till this?
Yeah.
Okay, fine. If there is no doubts, I'm moving on to the next one here. So the next one is like, again, in initial conditions itself, you have like a thermal calculations type as SE, that is like a steady state thermals you have it. Steady state thermal that you have it. Okay, you have something called as a steady state thermal. Okay, so when I need to choose this as a steady state thermal, here again, I have just plotted you an image. So in your phase, when you go for a thermal calculation type, and when you choose this as a steady state thermal conditions, that is where in your structures module, you have to create like a thermal flow boundary conditions. That means, yeah, let's say I'll show you in the software. Now you're going to your structures here, and you says that like, this is my image I'm talking about this. Okay. So this is what the image I'm just talking about. Okay. And if you just go to that particular image here, I have just clearly showed you like under the line that you have like a thermal flow boundary conditions. So you can just go here and create a thermal flow boundary conditions. Now I'm mentioning this, and this. It is all these particular things is all with behavior is a closed or if it is a temperature. So I would like to maintain the uniform temperature of, let's say, some 300 Kelvin. I would like to maintain a temperature of a 300 Kelvin. And now here also, I would like to mention the temperature. The temperature is like 300 Kelvin. And here also, I would like to mention the temperature for your soil, where again, this is a 300 Kelvin. Now I'm entering a uniform value, but if you want here 300, here 295, here 280, whatever you want, you can go it. No issues. When in your problem, when you have this kind of a boundary conditions, okay. Now, if you just click on to the flow conditions, it's showing, see, temperature is 300, that is by default. And when you have this kind of a condition, then it's mandatory that in the stage construction, you have to go for the initial phase. And in the thermal calculation type, that you have to make sure that this is an earth gradient. After the earth gradient, then you have to make sure the modal conditions, thermal flow is on. Sorry, I'm wrong. When you have that kind of a conditions, then you have to choose this as a steady state thermal flow, give OK, and make sure that this is on. The borders and all the temperature is constant. Now, if you switch on this or switch off that, it doesn't matter because the borders is constant. The borders is constant only onto the depth wise. If any temperature is there, if it is there, it is going to change, but the borders will not change. So if you have that kind of a conditions, then you have to choose this as a steady state thermal flow conditions for now. So now I think you got a better idea, I feel, when to choose an earth gradient and when to choose a steady state thermal flow. Is this clear, these two?
Yeah.
Yes.
Okay, moving on. Moving on to this. So I told you guys, like, when you are just trying to solve this particular problem, maybe I told you to remember this. Sigma m weight is always showing it as a 1. That is what I'm going to talk about. Sigma m stage or sigma m weight, both the same. That's going to be like 1. Okay, sigma m weight or m stage, it can be played in a different ways, but I don't want to make you a very complex understanding right now, but I would like to make you a very simple understanding of this. Yeah. You all know our politics very well. It says that, like, as a democratic country, we do follow dividend and rule. That's where, like, we have one prime minister, we have like some 28 chief ministers, and then under the chief ministers that we have around some so many MPs and MLAs, all these things are there, and the cabinet ministers are there. So this is where we know that if one person is there, he cannot able to handle the whole responsibilities. So what we have to do is the responsibilities has to be divided into a small parts, and he should be in a position to monitor what is going on at least. Okay, so this is what actually the dividend rule, or like you can take it of any of your best examples. My general example I used to say is like, if you're a foodie, how do you eat your favorite food? That's also the best example I can tell you that. Okay, let's assume that you are a very good foodie about biryani, and if you would like to eat this, the moment when you start of your first time that when you are trying to eat it, you try knowingly or unknowingly, maybe from now onwards you can check on yourself. Knowingly or unknowingly, you're going to take a little more quantity and you try to consume it. As long as you feel that your taste buds are good, you keep on consuming that particular quantity. The moment when you feel it's heavier to you, or the moment when you feel that you are losing your taste buds, then automatically the consumption, it will slowly come down. If you are eating with your hand, please assume that you are eating with your hand. Don't say that you eat with a spoon also. After some time that you try to take only the half spoon, but the moment when you touch it for the first time, you take it as a full spoon. Okay, so though the quantity is little more also at the end, but still you try to take it as a less, in meaning that like you didn't like that particular thing. So this is also similar to this particular process, what we call it as like a Newton-Raphson method. So this particular process in finite element analysis, we are going to call it as a Newton-Raphson method, and the same it is followed by any of the finite element analysis solvers to maintain the equilibrium about your problem. Equilibrium is like constant. Okay, now if you just look into this, I have an x-axis and I have a y-axis, and this is the how that you need to, your problem is behaving. Maybe you can just consider this x-axis is your time and y-axis is your load, or like y-axis is your load and x-axis is your displacements. When the load increases, the displacements also increases or something like this. But the behavior, the response of your structure, the response of your soil for the load applied and to the supplements is, this is the one. Now, if I would like to see this particular problem, actually what will happen is like, Newton-Raphson says that I can't study the complete behavior in a single shot, but what I do instead of that is like, I will try to divide this into a small number of steps. That is like step 1, step 2, step 3. He has been separated that. So the first thing is like, if you if you're going for a new place and the very first time that you would like to taste the food, again, you do like first time you will take only a small quantity. And if you feel liking it, you start taking it more and more. Okay, so the Newton Raphson follows the same thing. Every problem is a new problem. Everything is a new challenge. So first I will try to divide it into a 20% and then see whether I could able to solve the problem or not. If yes, then he would increase another 50%. And if yes, another he can go up to like 50% and then he can solve this particular problem over there. Now, what is this particular M weight actually? M weight, it says that because you are on the initial conditions, let's say that you have fed something like density, kg per cubic meter is the density that you have fed, mass by volume. So if you feed 100 kg per cubic meter is the density of your soil, let's assume that. Then if I consider here the initial conditions, sigma M weight is like 1, then it will consider that it as a density as a 100 only. But here, if I just keep it as a 0.9, though in the material properties, the density you provided is like 100, but it will consider it as a 90 only. For the calculations, it's going to consider it as a 90 only. So this is where that when your boss asks you to do, can you do me a favor saying that vary the densities of your material and confirm me the behavior? If he says like a 10 different densities, are you going to add all these particular 10 different densities to your material properties and 10 different material properties you need to create it? And each time that you need to change your material properties and all? No, that's as simple as thing. The M weight that you can able to change this particular values. But this, the first case, I consider it as a density as like this. But in the second phase, I would like to consider this density as like only 0.9. As just 0.9. Okay. So initial cases like 0.6, this I would like to consider as a 0.9. Now, again, click on this initial phase. From the initial phase again, this particular case, I would like to consider the density as like 0.8. That is 80% of the density you provided. That is only it is going to consider it. So that's why leave it to 1. But when your colleagues are working on something, sometimes if this value is changing, your results will never match, and don't break your head at that particular point of time. I don't know what's happening to this.
Again, your command has become infinite queue.
It's telling me to buy a new laptop.
That queue, I think key getting pressed non-stop.
Yeah, fine. So now this is what actually the sigma M weight says that you are playing with the densities. Then what is the sigma M stage? M stage plays a role with your inputs. Let's say that if you are feeding 100 kilonewtons as a load, and now if you say that sigma M, oh my God, sorry. Oh, no.
This is there to trouble you.
Come on, don't say this, cancel. Hey, come on. Okay, anyways, I'm not going to save it, but the original copy is already available in our link. So you guys are going to download from there only. Okay, now you see this. Now if you say M stage is 0.5, that's only the 50% of the load it is applied. That means if you take this an M stage as a 1, out of 100 kilonewtons that you are applying it, it is going to apply only 50 kilonewtons. That means that the densities, if you want to play, you can play with sigma M weight. And if you would like to play with your weights also, you can play with this. But suggestion, until then you become a super expert, don't touch these values. Suggestion. Until then, you become a super expert and comfortable. Don't touch these values. And majority of the places people won't tell you the importance of this. But why I'm telling you is like when you just look into your solution, make sure that in the initial conditions, the sigma m stage and sigma m weight are 1. Okay. So, and that's how actually the Newton-Raphson says that when you say sigma m stage, while solving a problem, I ask you to remember this particular window. Okay. While solving a problem, what happens here? If you see the sigma m stage, now it is like 0.83. 0.83 means 83.66% of the load is applied till that particular point of time, till that particular point of calculations. Okay. So at that particular point of things, if the stiffness is coming down, see now you have to observe this particular table and your solution is running for a very longer intervals of a time, running and running and running. You have to observe whether the stiffness is increasing or stiffness is decreasing. When the stiffness is coming down, it indicates that soil is collapsing. It indicates that the soil is collapsing here. So study the results based upon the numbers. Study the results based upon the numbers. Yeah. Now, for this particular problem, the Newton-Raphson says that I would like to take many steps. Maximum number of steps it can go is like 1000, but the current step it is solving is like 13. Okay, don't look into all the numbers today itself. I'll slowly come each and everything. But the very important things I'm just touching it now. Okay. Yeah. Now, if you apply a displacement, then you can see fx and fy value also. So from this particular image itself, I will understand that there is a load applied on this particular problem, not the displacement. If the displacement is applied, then I could see fx and fy values. It will not be like 0 and 0. Okay.
Other way around, I have a question.
Yeah.
You're applying the load, let us say 50%, then 80%, somewhere 100%. It means if you construct a high-rise building, is it as good as completing 30%, 50%, 80% of the total height for the building?
Don't compare
Means
the structures with this. This is what the displacement or the load that you are applying. So if you apply 100 kilonewtons of a load, it is not consider the construction stages, only the load or only the displacement.
Mhm. Okay, thank you.
Input value. If you see that what you are calculating on all your analysis is like your stiffness multiplied by the displacement will gives you the force value. K into x equal to the force. This is what you are trying to solve it in any kind of a problem. Either you give displacement as an input and calculate the force as an output, or you give force as an input and calculate the displacement as an output.
Mm.
Okay, so now it makes sense for you, like when you are looking into a problem, understand that which type of analysis also it is. I mean, what kind of an inputs also we were feeding this over here. Okay, so someone sends you a screenshot, then you have to see that if here the density m weight is like 1, then they are considered 100% density. But here sigma m weight is not 1. If it is like 0.7, then they consider only 70% of your density. So you have to go and question and check with them. And sigma m stage, so people says that, okay, the problem is done or something like that. But if the sigma m stage here, it is showing something like 0.9. No, the problem is not done till 10% of your solution need to complete. Okay, so remember this particular values. It makes sense. You can able to remember this, right?
Thank you.
Yeah. So this, wherever I go, it's done. Okay. Oh. Better not to do this. Okay, so you just guys go here, and if you have any doubts till this, I would like to take a pass, and if you have any doubts, let me know. And tomorrow again, that when we are meeting it, I will explain you about the remaining things too as well.
Thank you, sir.
Okay, thank you then. If there is no doubts, I think we can close for the day. If you have any doubts, I'm open to discuss. Okay,
Thank you,
considering
sir.
your silence,
Thank you.
there is no doubts. Okay, thank you all then.
Thank you.
Tomorrow again, we'll catch up at 8 to 9. There's some chat. Okay. Maybe someone who is there in the chat, can you hint me? Today, my laptop is not responding so great. Maybe I need a battery start. Is all good, guys? Okay.